Alright, good morning everyone. My name is Ling. Flown in from Geneva today. A bit about my background. I'm a software engineer, wannabe data scientist. My starting in life with coding was buying a magazine in a shop, typing in several pages of code to create a computer game back in the days where tape drives were the thing. So that's how old I am. I'm lucky to be Chinese because actually, I'm nearly 50, but apparently I'm still quite young. So, all right. So how did I get to Numerai? Well, I was actually working on this thing called Holly, which I wanted to build an async web-based web developer. And I was talking to a friend about it, saying, "This is really cool. I've got a web developer thing." He said, "Can you use this to solve data science problems?" I was like, that's a good idea. Oh, by the way, I'm looking for contributors or people to help me. I'm going to look to try and open source Holly, so if you've got some spare time, feel free to ask me to catch me later. But could we use this to solve data science? And it's like, that's an interesting use case. And I was like, well, I've always looked at Kaggle, never had time to go and do a Kaggle competition. So I thought, well, let's go to Kaggle, take the opening competition, throw the problem to my setup, and I was like, wow, this is amazing. I've got 350th position just from firing this in. And I told my data science friend about it, and he said, Ling, this is this is cool, but you probably just, the solution is probably online somewhere, and so the LLM is just regurgitating that solution. And I was just then, okay, cool, I've got a prompt engineering later, made it to 25th position, I'm like, this is cool. And then my friend then called me a few days later and said, hey, Ling, this is cool, but can you do it on Numerai? And I was like, what is Numerai? He said, well, apparently it's the hardest data science challenge in the world. I was like, okay, cool, let's do it. And then he said, there's probably not so much information written about how it works, because obviously if you've got a working model, you may not want to share that with the rest of the world, because obviously it's valuable knowledge. So I was like, okay, cool, let's give this a go. So before I go into it, I presume everyone knows what vibe coding is, but did you know that it was actually coined by Andre Carpathy, a bit of background? And it's a kind of coding where we call, you're sort of embracing the AI and just closing your eyes going like, press the button, it's going to work. So I'm now sort of saying, okay, it also has a bit of negative connotations, because if you're not a software engineer, it's like, you're just vibe coding your way through. So I came up with this concept of vibe modeling or vibe predicting, where I'm not a data scientist. I'm sort of doing what a vibe coder might do. So I'm just going, okay, AI, can you just build me a model and solve this? Here's the data set, and solve this for me. I just thought I'd put this evolution of coding. So as I mentioned, my youth was spent typing in code and looking at man pages, and the evolution of coding has evolved, and now we're into a world where it's so easy to, if I was back in my teenage times, just to speak English into, AI and just write code, that's like amazing, isn't it? But if you're interested in some of the vibe tools I do use, a mixture of the frontier models, so Claude Code, Codex, Gemini, these are some of the things I use. There's also lots of really cool open source, so open weight ones, Communicate2, Quen3, and plenty of others out there, if you have enough hardware to run that is. Right, so, let's see. So I went, let's take the data set, throw this into my AI, and go, ta-da, here's a model, I'm just going to start predicting it, and yes, it didn't really work. And you like my little lemming just dropping off, and I'm like, the first thing I'm like, cool, I've got a model, this is super easy, like I'll just throw in all my money into it, and then a month later I'm like, this is not quite right. And then my friend said to me, well, you should be doing what a data scientist should be doing, and rather than just throwing everything in, you should be following proper data scientist procedures. Like, what does that involve? Well, EDA, exploratory data analysis. So it's like, okay, you need to go into notebooks, have a look at the data, figure out some stuff. Like, well, of course I'm not going to do that, because I have no clue on how to do that. So, and all this feature engineering and implementing models, using things like weights and biases to see if you've underfit or overfit your models, fine-tune your models, optimize the hyperparameters. All of you data scientists probably know this. This I've learned in the last 2 or 3 months. So then I was like, well, I don't know how to do it. I'm sure the AI does. So I'm like, okay, can you, Mr. AI, do the EDA for me? Give me a report and everything, and then just tell me what the data looks like, what do I need to do? And sure enough, after a bit of prompt engineering, it says, ta-da, here you go. I've shared that in a GitHub repo that'll be public, so if you want to have a look at some of the EDA results, it talks a lot about era-wise training, which those are the people who have been doing this for a long time and know all these tricks and stuff. Bear in mind, I'm only sort of month 3 into Numerai. Okay, so context engineering is key. So from my sort of software engineering use of it, it's all about giving background and details to LLM, giving instructions, and then you can try different models, you can build things really quickly, which is awesome. So for this thing, I can then now build lots of different models with the EDA analysis. I can feed back as part of that. And of course, like XGBoost, if you're vocabulary, that's like a sort of pretty typical model that everyone uses to solve Kaggle competitions. And it's like, okay, cool. Hey, can you use XGBoost to build a model? And actually, this probably answers your question of like why you get negative MMC. And this is my deduction, is because probably a lot of people are just using XGBoost, and because it's not very unique, you get penalised in it because every Tom, Dick and Harry is using probably XGBoost to try and solve the Numerai problem. But you get the positive core value, right, which is probably what you're seeing, because the predictions are great, but everyone else is doing it, you're just copying the same model. So, cool. So I'm like, okay, well, let's optimize for MMC, right, because that's where it is. And I'm like, okay, cool, let's do all the good things that we should be doing, feature engineering, bells and whistles, look at how to do ensembles, look at how to do feature neutralization, hyperparameter tuning. So this is something I've been learning in the last couple of months, and actually getting AI to do a lot of this stuff. So vibe, predicting. And, this was one model I built that initially produced. I was like, oh, it's not kind of working. Left it alone, and then, a month later, I'm like, hold on a second, what's going on here? Right, well, that looks quite reasonable, I suppose. I don't know, but I presume it's looking quite reasonable. And then I tried another model, so an all singing, all dancing model, so built a few more models here. Again, that's sort of negative back in August, and it's just been going quite well. So I've just literally, it's just a bit of prompting and a bit of, so saying try building this model and all this sort of stuff. I haven't honestly looked at the code as a vibe coder would do as well. So these are some of the result, which is I think it's quite amazing. But anyway, and then hitting the spot, when you get these emails every day, I kind of like seeing the sort of little black dot on the far right means that your model is doing something positive, and the ones on the left here, I've also, part of what I started doing was I did the initial tutorial, and then I used those models, submitted those models just as a reference to see how they fit. So they tend to be like these dots over here, and so forth. And you can see this is my first model I built where it said okay, let's risk all my crypto and see what happens. So that's that. But also there's still a lot more room for improvement. So I've been learning a lot of things, like for example, we could retrain the models because the validation dataset grows every week. I didn't honestly know about this until last week in a Discord conversation. It's like, that's cool. So that's another avenue to look at. Pruning, taking a concept from sort of LLMs and neural networks where you train a huge neural network and then you can prune this to a smaller network, and then you can and you can some interesting things on that sort of side. So something to experiment and explore. Training strategies. So maybe looking at different training strategies, rolling windows, experiment with different sizes and things like that. Looking at mixture of experts and ensembles, basically creating lots of different models, putting them together, and then submitting them that. And I think as Alex was saying, I do use, because AI can spit out models so quickly, I can fire in my account on, I think I've got 15 models at the moment out of the maximum 19. They're all running, and then the good ones I basically say to the AI, this one's working, this one's working, can you kind of merge them into an ensemble for me, and then deploy another one. So that's another cool trick. So conclusions. I think AI-assisted coding helps. I still have no real clue about data science. Well, I have some clue, but I'm not a true data scientist. I'm probably an imposter in some ways. But the next steps, I guess, I would love to have a crack at signals. So I'm currently getting AI to do the data extraction, so I don't want to go through and pull data out. And I would like to run a similar process as before, and let's go. And hopefully, maybe I'll get to a Grandmaster in Numerai, and yeah, and that'd be quite cool. And also, I have a bit of a competition with my wife, that she works in finance in Geneva. She runs a $3.5 billion green energy transition fund, so she's a value-based investor, fund manager. So what she does is, it's very interesting, it's very different to what we're doing here. So her strategy is she will speak to the CEOs, CFOs, and really understand the business, and then place her bets and so forth. She does very well from that. So this is, what we're doing here is completely the other end of the scale. So it's quite fascinating. So if I can, my challenge is that if I can make more money than my wife, then game on. So yeah, I think that is my talk. I hope that's been useful. Happy to take questions.
Can you go back to that payout slide? I think that's like that. I think that's like the perfect explanation before of the negative MMC. Because I don't know if you guys can see the gray, right? Yes. That's the all models. That's like all models that are submitted, but this is, I think, where you can actually visually see like the magic of Numerai. Because you can see that the distribution is offset positively on the models that are staked. So if you're staking and you're getting negative MMC, you're like offset to the left from that. So hopefully that makes more sense. I didn't mean to take over.
It's good.
I just thought that was like a good graphic.
Yes, sir.
So 2 questions.
Thank you.
So what are you using? Are you using Codex?
So for all of this, I've been using Claude. Codex 5 only just came out a couple of weeks, about a week or so ago. But what I tend to do is I tend to do an initial planning stage with an AI. So O3 is pretty good, Gemini is pretty good. I'll just talk to them like, hey, how does this model work? What about this edge case or these trading patterns? And then quite often I apply the same, what I do for software. It's like, can you write me a software requirements document for doing this? So it's basically, can you write me a software requirements document for a data scientist to implement a model to solve for Numerai? And then you have a bit of a chat, you then end up with this requirements document, and then you throw that into Claude, and then basically get Claude to implement that in code, and then you just run the training.
And then you come back the next day, and how do you keep your chat going? Like you can save these chats, so you only has to read again what you stored on your machine.
You can totally save the chats on your. So if you're using Claude, whatever, you can download the conversations from. If you're using Claude Desktop, if you're using Claude Code, that is also saved on your drive. It's in a there's a sort of JSON file that's all hidden, but there's some open source packages that you can retrieve that. So you can get this conversation. But the code is the end of it. I suppose, so you just kind of know what to chat about and stuff, or I have like some sort of system prompts I keep, in place. But once you've got the code, sometimes what I've done is I've had one model works really well, one doesn't. And another cool thing that you can do is to say, hey, can you look at the code for this model and versus this model, this works better, why? And I'll go, oh, because this has got feature neutralization implemented. Like, oh, cool, okay, well, can you implement it for this other model which doesn't have it, and then I can run that and you can see then the results improving and so forth. So, and I'm not looked into the code, I've just got the AI to do the analysis and everything and build everything, and I'm just hitting tab as the vibe code is like do. I'm just hitting tab as a vibe data scientist.
Okay, last and very quick, and how long do you wait? Every time I use Codex, it's like it works, but it's boring. Then do this, and then it analyzes the code. Not the training itself, that takes time, but while it analyzes, it's always boring. It's Claude the same.
Sorry, is it boring?
Like you say, can you do this, and then it reads to your code base and so on, and you can just go to get coffee and another coffee. And
exactly. So the Holly project, the idea for that was to be able to have a thing where you could have, basically have a thing where you have on your mobile. And my idea is when I'm doing the school run, take my daughter to school, I've got this great idea. I just want to be able to type something in. in the background that will kick off a process to, update some code or whatever I'm doing. And then when I come back home, I've got sort of a PR request waiting for me. I can review the code, and and I think this automation is great because I want to be able to do stuff or do more stuff, right? So like if I've got like a little engineer working in the background and I can have a cup of coffee or chat to everyone here, well, why not, right? It's kind of just what you say.
Yeah, I wanted to ask about the model training. So you still need to run your training somewhere. So how do you do that?
Yes.
It could be that your AI comes up with something super complicated that needs 3 days to train.
Yes, so as a sort of failed up serial founder, I managed to sort of own 2 A6000 GPUs with 256 gig of RAM server and data center back in the UK. So that's been collecting dust. So that's not collecting dust right now. This is just running models and doing all sorts of crazy stuff. Sort of probably as we speak. But yeah, it's quite nice. It's quite a nice problem to solve. One of the things I used to do was when I was working for a bank was we were doing some distributed compute for all the risk models we were building. So it's quite like the techie stuff and having these distributed compute doing stuff for you. It's quite, I don't know if I find it quite exciting, but just there.
Hey, that's very interesting. How do you keep track of all this branching AI suggests? Because I can imagine the complexity explodes very quickly because it goes, hey, let's try this one, let's try this one. Do you have like any system where you keep all these iterations over?
Yeah, so I think GitHub is Git, and GitHub is the friend. So whenever I'm making code changes, it's going straight to Git, so there's an audit log of it. Actually, one thing I'm actually going to start writing is the history of my journey of how I got to where I am. But what I've done is I've asked the AI to look at all my GitHub code commits and start writing like a sort of a story about that. So that will be coming soon. Such soon, but at some point. But yeah, so Git, typical software engineering practices. Like put stuff into Git, create feature branches, run your code. I mentioned about weights and biases, so I got the AI to connect into weights and biases to then, because weights and biases records all your training models, you just tag everything, so you can try different models, and then I have in my deployment process, I do use a bit of a cloud pickle, but on my own server, I've got it set up such that I get the webhooks from Numerai, and I've got sort of like, for my different models I get webhooks in, that triggers jobs to do the predictions, and that's all logged and everything, so yeah.
So you basically expose like all the metrics you care about along with some like code changes in the Git commit, and then you feed it back to the AI whenever you want to iterate?
Yeah, so the AI can just read, all the code is already committed to Git, and then it has access to my Git repo, so I can just say, hey, take a look at this model, can you tweak this, or you can actually hook it up into like weights and biases APIs and stuff, and get it to have a poke around and things like that.
So you have like a cross-link commit to the Numerai, the 1DB, and you see the AI can see everything.
Yeah.
Right. And do you run experiments in parallel as well?
Yeah, so all the experiments I'm running are the ones that are on my account, so I'll just put models up and then just let them run. It's frustrating because the coding of the AI pieces and the training is relatively quick, but when you go out to the real world, you're like having to wait exactly this 20 days, you're like, oh, can't this go faster? So it's just, I guess as I was talking to Jennifer today, it's about patience, and it's like, I don't know, but there's a bit of a dopamine hit when you get this email every day to see how are your models done or not, and then sometimes just weirdly the market just seems to change, and you're like, okay, well, why was it working before and not now? Have I undertrained it or overtrained it, or there's all these questions that I'm always asking. So and then leads me to try and retrain the model or tweak things and so forth. But it just takes time as everyone who's done this.
Gentleman in the back? Is DLC1 deep learning? Is that what that means?
So
It says DLC1D8 at the top.
Oh, so the DL, so basically here, this is one of my models, DL, so that was a deep learning, C1D8, that's just a hash code I have. This was the first one I built. I was like, okay, here's all the data, create a deep learning model, go crazy, train the model on all that data, and it should work right at first.
So the question is, do you think that maybe Claude, do you think maybe Claude overfits because it's just a little more complex to train a deep learning model, and that's why the boosted trees wins, because it's just a little simpler?
So it's not Claude that's doing the fitting necessarily. So when you're training the training model, you need to kind of figure out when you want to stop the training. So
does it give you the architecture?
yeah. So well, Claude creates the architecture, but it's more about the when you're doing the training itself. I'm not the expert, but probably other people here will know training deep learning models better. But let me just sort of say, let me see if I can find. A second. So basically, you can, when it's training, for example, let's see.
You can't see it on the screen yet.
Oh, okay. Okay. I'll share with this later, but basically, I use weights and biases. So basically, during training, it will send sort of the training results as it's going through all the data, and then that will give you, it'll do a plot of the loss rate, and what you'll see is like sort of when you're doing your training for validation and loss, you'll see a sort of curve like this. And then I think, I feel for me, it's a bit of an art form of when you want to stop training and when things are either underfit or overfit. And I think my first attempt was just let it run for 50 epochs, whatever it is. But I obviously haven't, at that point in my journey, I haven't got that intuition of like when to stop and do you use a bigger learning rate, a smaller learning rate, all sorts of things. I have on my to-do list to use Optuna and sort of do hyperparameter tuning, but yeah, it's on SEC sort of exploratory list and everything. So there's definitely more to tune, more to work out.
Yeah, this actually relates to my next question, whether you have done any AutoML experiments.
I have not, but I was talking to a brilliant gentleman about it, so I think this is going to be my next mission. I was saying that the EDA part of it with Ling was really cool, and that was pretty much automated. So I wonder if I can get the AI to do the AutoML, or to automate the AutoML bit. I don't know, maybe, but it's another interesting journey to explore.
I'll just go on. What's your time commitment on Numerai so far?
My time commitment, gosh, if you ask my wife, probably too much. But actually, I mean, in terms of time commitment, I'm into this month. So I started in July, and literally, the biggest pieces were getting the infrastructure going on the server, building some of the models, and then I think the last month I've just sort of forgotten about it and then just kind of get excited sometimes. So probably not a huge amount, maybe, a week or two, something like that. I don't know. Yeah.
A week or two a month?
Total.
Okay.
Yeah, something like that. I don't know how that compares to where the sort of the long time Numerati people.
Don't ask.
Okay. Okay.